acts as a resistor which withstands the energy between the electrode and the workpiece until it gets high enough for a spark to jump across and erode material. It also flushes away the eroded debris as the hole is being created. This is the guide that supports the rotating electrode and enables us to position the electrode precisely. And here is the table where the workpiece will be clamped, and the frame of this creates an electrical circuit. At the rear of the machine there are the generators, pumps and a filter system, and they clean the dielectric. And finally there's a resin ion exchange unit, and that ensures that the water that we use has the... This is particularly useful for situations where compound angles are needed, and the fixture is greatly simplified. Here we have a machine at 45 degrees. Automatic redressing. This function enables the tip of the electrode, the tube, that gets worn and eroded in a dome shape to be redressed flat by the machine during machining, without the electrode having to be replaced. This is very useful if a flat bottom hole to a set depth is required. And here you can see the electrode being eroded, but the part isn't, and that's making the electrode flat again. Depth sensors. The machine has a function which calculates the wear of the electrode during drilling and resets the depth accordingly. Thereby the correct depth of hole is achieved by compensating for electrode wear. You see this now as it pitches across, checks its depth that has been drilled against the wear in the electrode, and then returns itself to the hole that has been drilled and re-drills to the correct depth. Here's a thin section where we've drilled this array of holes without deforming the part. And then here's a part where we've drilled a deep hole right the way through. We can drill a hole up to 340 millimeters in depth using the EDM hole drilling process. Finally, here's a component where we've drilled an array of holes, and we've used the CNC function to control this process. And now we're going to look at our EDM hole drilling machine drilling a hole in some stainless steel. We'll now set the EDM hole drilling machine running, drilling a test hole. We're using a 0.6mm brass tube, and we're going to drill at an angle so that it's easy to see. On purpose, we've not clamped the part into the machine. We've done this to show that it is the spark that drills the hole, and there's no load from the electrode. The part is only moving very, very slightly, and that is a result of the high pressure of the dielectric fluid being jetted through the center of the tube. Now that the hole is through, you can see the sparks. You can see the dielectric fluid and its high pressure. Use a hexagonal shaped pocket, an internal spline or an external spline electrode, a barrel shape, or even a threaded electrode. The electrodes can be made of or even copper tungsten. The electrode and the workpiece are surrounded by oil. The spark corroding across the full face of the electrode so that you can see the spark corroding happening. You can see smoke being extracted, and you can see the oil getting dark from eroded particles. The oil, as well as being a resistor, is used to carry away the eroded particles. It passes through a filter system and a chiller, and then is flushed back in front of the electrode. Spark corroding works best with clean, chilled dielectric fluid. The pecking motion of the electrode also helps tank clean dielectric into the space between the electrode and the workpiece. If we now stop the electrode machining and lift it, you can see the eroded shape.